Hi, everybody. Happy Monday. I missed seeing you last Friday when we had all of our meetings that day. Hopefully, everything was great for you on your day off. You get to sleep in and take a break from your computer. So, welcome back. This is a very important week for you. Okay, with your learning specifically for you guys for algebra going into honors geometry or integrated for next year, this is a critical week of instruction for you. We are going back to chapter 5 and we're covering a few skills that I was really hoping to cover in person with you, but due to circumstances will not happen. Sorry, well, I'm about to cry here. But we're going to cover them all throughout this week. Now, technically, this is only 2 lessons, but notice that I'm taking all 5 days to cover it. That's how important it is to me that you really understand and you can really demonstrate your skills, because after being at the high school and observing, I know for a fact that this is going to come up for you heavily next year. So what we're talking about today, number 1, we're going to review slope-intercept form. This should definitely be a review for you. We're going to talk about parallel and perpendicular lines. I'm not sure how much we covered that in class. I can't really remember. So it might be a review, might be something new. It's pretty simple. And then we're going to talk more in depth about standard form. Now, I know that you've been exposed to that, but I don't know how much we've truly looked at it and learned about it. So we're going to do that today. It is so very important that you really actively engage this week and that you take the time to take notes and spend time on your assignments and really make math a priority. I'm telling you, I wish I could convey it as much as I can. Learning about slope-intercept form, standard form, point-slope form is so critical for you guys for next year. I really want to make sure that you have it down and you have it mastered, okay? So every day for your math lessons, make sure that you have your math spiral with you. At the end of the week, we're going to create like a long T-chart on like a Google Doc, or like I'll push out a PDF. I haven't really decided yet on a way that we can just have all of our notes about all 3 forms synthesized together, so that if you want to look back at it next year, you have that. Please make sure that as you're watching the videos, like if you have questions, write them down and message me, or you can post it on my update in the morning, because I bet if you have that question, other people definitely have that question as well. So here we go. Here are the skills that we're going to be looking at today. You should be able to write an equation for a graph in slope-intercept and standard form. We will probably look at the standard form part a little bit more tomorrow, but we're going to touch on it today. We're going to identify x-intercepts and y-intercepts from standard form and from graphs, and we're going to be able to graph lines in slope-intercept and standard form. So let's start with a quick review to make sure that we're all on the same page in terms of the foundations here. If I asked you to find the slope of this line, okay, all you really need to do, so if you're looking at a graph and you're asked like, okay, how do you find the slope? Identify 2 points on the line that go perfectly through. Now this graph kind of already had them. Notice that we are going to go down first. So we're going to go down 1, 2, 3. So that's down 3, and then over 1, 2, 3, 4. So because we went down 3 over 4, my slope would be negative 3 over 4. Okay, pretty simple. Now, you can also find the slope from 2 coordinate pairs using slope formula. So remember, this is what it looks like. I'm not sure how much we remember using this, but start with your coordinates as x1, y1, x2, y2, and then you can just plug them into the formula. This is something you might want to write down if you don't think that it's going to come quick to your memory. Once you have the formula written out, you can just go plug in your values from your coordinate pairs, which would look like this. What I'm just going to caution you on is, remember, when you do 2 minus a negative, that minus a negative is going to turn into a positive. So that's actually going to turn into a big addition sign. And I'll draw that in there for you as soon as my smart notebook doesn't take 1,000 years. So it would look something like this. And I know 2 plus 3 is 5. 3 minus 4 is a negative 1. Now when you simplify that, 5 over negative 1 just simplifies to negative 5. Okay, so you can find slope from a graph, and you can find slope from 2 coordinate pairs. All right, here we go, you guys. There are 3 different forms of linear equations that we're going to look at this week. So we're thinking linear equations, equations that would produce lines on a graph. Form 1 is slope-intercept form. We know this form. We've worked with it. We are well versed. But start with your notes. Start Form 1, slope-intercept form. It is y equals mx plus b. Ladies and gentlemen, I put this on a t-shirt and I wore it to school one day. Oh, I should have worn it for this video. Dang it. Okay. M is your slope. B is your y-intercept. If I gave you these two equations here and I asked you to graph it, let me use different colors to kind of show this to you. And hopefully this is just a review and you're like, Miss Levan, we already know this. And I'll say, good, I'm glad. All right, so remember that we're going to start with our y-intercept of -3, 1, 2, 3. And then we're going to apply our slope of 2. So you're going to go up 2 over 1. There's your dot. Up 2 over 1. Up 2 over 1. And then you would connect using lines. If I was graphing my green equation here, again, I even just do this to help myself out. I always circle my y-intercept so I know to start there. So I start at 1. And then if my slope is -2 over 3, I'm going to go down 2, right 1, 2, 3. Now, I can either do that again, or I could do the reverse. I could go up 2, okay, and then left 3. As long as one of your directions is negative, that takes care of the negative slope value. And notice that all your points are in the same line, and there you are. So that is graphing a line in slope-intercept form, which again should be review. Now I'm sure that you can guess, or if you can see my slides on the left, we're now going to do the opposite process. If I give you a graph, can you tell me the equation in slope-intercept form? So let's look at this one right here. Notice that we always start with our y-intercept, noticing where that lies, that point is on the on the y-axis. And let me grab my highlighter for you so I can highlight it. Okay, so we see right here that on that y-axis, the line runs through -2. So that is my y-intercept. Then I need to go find another point that's perfect on the line. And this one looks great because it goes right through those two boxes. So if I was writing the equation, I know that I need to find my slope first. So I'm going up 1, 2, 3, 4 over 1, 2, 3. So when I put that together in the equation, it's going to look like this. Y equals 4/3 x, because my slope was 4/3, I went up 4, right 3, minus 2, because my y-intercept is -2. And that's the equation for that line. And it went away. For this guy over here, okay, let's start by identifying what our y-intercept is, aka where it hits on that y-axis. So I see that it's right here. And then my slope, I see that it's going down 1 over 2. So if I plug that in my equation, I would have y equals -1/2 x. Remember, it's negative because our equation is going down, plus 2. And it's plus 2 because our y-intercept is on the +2 for your y-axis. And then there's your equation. Notice that it is in slope-intercept form because you've got your y, your x, and then your constant there. So there we go. Okay, now this is the part that might be new, it might be review, but make sure that it's in your notebooks, make sure that you are detailed with your notes. When we're talking about parallel lines, we know that parallel lines never intersect. They will never touch, they never intersect, and they're often denoted by these markings here. So you can see like 1 arrow, 2 arrows, etc. Perpendicular lines are lines that meet, and when they meet, they create a right angle. Okay, so they intersect, they almost form like an L, and they create a right angle. There are different stipulations for the slopes for parallel lines and perpendicular lines. When we are talking about parallel lines, those lines will always have the same slope. Always. They will always have the same slope. So notice that these two guys here, like if you were just looking at their equations, you see 2x and 2x. I could just give you those equations and you should know that they'll produce parallel lines. Okay, if I said like y equals 5x plus 1 and y equals 5x minus 100, you don't even need to graph. Those are producing parallel lines. With perpendicular lines, we know that the slopes are opposite reciprocals. Opposite, meaning one is positive, one is negative, and reciprocals, if you start with 2/3, you would flip your fraction and make it the reciprocal. So notice, you've got 2/3. Up here, we made it the opposite by making it negative, and we flipped it to 3/2. If I gave you a slope of 4, the opposite reciprocal would be -1/4. If I told you that a slope was 1/7, and I wanted the perpendicular slope, you would tell me -7 because it'd be -7 over 1. Okay, so now, especially thinking about next year, you might be asked to write, maybe say you're writing a system of equations that would produce parallel lines with parallel slopes. All you need to do is just create you just need to write two equations that have the same slope or the same end value. So let's say you've got y equals -4x plus 1, and then your second equation would be y equals -4x minus 100. Doesn't matter. As long as they have the same slope, -4 and -4, you're good to go. Then if I asked you to write two equations with perpendicular slopes, you know that the coefficient of x in that equation they have to be opposite reciprocals, okay? Let's say that I'm starting with y equals, 4/7 x plus 1. When I come down here to write the opposite reciprocal to produce perpendicular lines, number one, let's make it the opposite. So if this guy's positive, I know this one will have to be negative. And then if I have 4/7, flip it, make it 7 over 4. So it's just 7 over 4 x, and then you can pick a y-intercept. Boom, there you go. All right, we are moving on. Form 2 is standard form. We are really starting to dive into this new content, and we're going to really dive deep into this linear form. Standard form is ax plus by equals c. Okay, but you'll always have numbers in for a, b, and c. A, b, and c are real numbers. They're not imaginary. A and b cannot be 0. A and b cannot be 0. Okay, and they're integers. You will not have any fractions when we're working with standard form. So that's an important note. You will never have a fraction when you're working with standard form. The advantage of using this is that you can quickly find your y-intercept and your x-intercept to draw a quick line, and I'm going to teach you how to do that. We've never seen x-intercepts before, so exciting day. All right, here we are. Standard form allows us to find our x and y intercepts quickly so that we can graph. Now, this should be familiar to you. This is the y-intercept of the graph. We know that this point is at 0, 2. This is important for you to hear and for you to understand. When we have the y-intercept, our x value is 0. When we have the x-intercept over here, wherever it crosses the x-axis, notice our y is 0. So let me say that again. When you have a y-intercept, x will be 0. When you have an x-intercept, y will be 0. Okay, and you're going to see that come into play today. There are two methods. If I'm asking you to either find the intercepts, just tell me their values, or if I'm asking you to graph an equation in standard form using the intercepts, there's two ways that you can do this. Substitution is the very mathematical way. This is proving why it works. Cover up, I'm guaranteeing, is the way that you'll probably do that. This is what I did when I was in math class myself. It's very quick and easy. So I'm going to show you with the same standard equation, standard form, I'm going to show you how both methods work. So let's say here I am. I give you this equation in standard form, ax plus by equals c. Notice that you've got integer, integer. This is another integer, but it's also a constant. And I want you not only to find those x and y intercepts, but I want you to use them to graph. So here's the substitution method. So let's say that I first am going to find the x-intercept, where it's going to cross on my x-axis. So here's just the equation drawn out. Okay, if I'm finding the x-intercept, I am plugging in 0 for y. If I'm finding the x-intercept, okay, I'm going to plug in 0 for y because look back here. When I'm finding that x, y is always 0. So when I do that, I know that that will produce a 0, and then I've got 3x equals 12. Hopefully we've got some good mental math going, and we know that x is going to be 4. Okay, now that I know that x is 4, I can come up here and I can plot that x-intercept on my graph at x equals 4. So let me grab my pen, not my highlighter. Okay, so we know x is 4, so I'm going to come over here, 1, 2, 3, 4, and I'm going to plot my point. Okay, now if I want to find my y-intercept, again, start with your baseline equation, the 3x plus 4y equals 12. If I'm finding y, make x 0. Okay, we know that when you multiply 3 times 0, it's going to become 0, and we're going to be left with 4y. If 4y equals 12, we know that y is going to be 3, okay, based on basic division. So now I know my y-intercept is 3. So I can come over here, come back to my y-axis, 1, 2, 3. Now that you have those two intercepts, you can connect them with a line and you've graphed that equation. Hopefully yours doesn't look as horrendous as mine does. Oh my goodness gracious. So if I give you a line in standard form, you can find the x-intercept and the y-intercept, plot them, graph through. Very simple, okay? Here's the cover-up method, okay? And I bet that you guys will like this, and I'm going to prove to you that the graph will be the same. Here's the little saying that I even wrote out to myself in my notes when I was back in middle and high school. To find the x, cover up the y. To find the y, cover up the x. So let's start with the first one. To find the x, cover up the y. So let's pretend, hold on, let me make sure that this actually covers it up. 1 second. Okay. Now we should be good to go. So if I'm finding my x, I'm going to cover up the y. So now I see it's just 3x equals 12, which I know then x is going to be equal to 4. Okay, just that's a basic one-step equation. Now to find the y, I'm going to cover up the x. So we're going to pretend like this is gone, and it's just 4y equals 12. If 4y equals 12, I know that y equals 3. Okay, and that's my y-intercept. This is the exact same as what we found on the other slide using the substitution method. So whatever method works best for you for finding the intercept, whether you're like physically like drawing out, you're going through the algebraic process of plugging in 0, okay? Or if you're just using the cover-up method, just remember, if you're finding x, cover up the y, make y 0. If you're finding y, cover up x, make x 0. Okay. Now let's look here. If I just asked you to find the x and y intercepts, which you will be asked to do on your assignment today, let's just use the cover-up method. That's what I'm going to go with. If you hate it, fine, whatever. Just kidding. All right, let's say that we're going to find the x-intercept first. If I'm finding x, I'm going to cover up the y. And let's pretend that the box is large enough to cover that whole term. If 5x equals 60, divide both sides by 5, I know that x has to be 12. Okay? That means x is 12. That means my x-intercept is going to be 12. Now, if I'm trying to find my y-intercept, this is what's important. Do you see how this subtraction sign is in front of the 6y? That is part of that term. So your equation is technically negative 6y equals 60. Divide both sides by negative 6, and you're going to get that y is equal to negative 10. And then that's your intercept there. Now, if you had a graph, you could go through and you could plot both of those and connect them really quick to the line, but that's just a really quick example of if you just had to find the intercepts, what you would do. Okay, let me show you one more time. If I asked you to graph an equation in standard form, could you change it to slope-intercept and graph it? Yes, and I'm actually going to show you that in tomorrow's lesson, so just hold on, okay? Just use my cover-up method for now. All right, so let's say that we're just going to use the intercepts. Let's say that we're going to find my y-intercept first, so I'm going to pretend to cover up my x. Now I'm actually going to take my hand and cover up the x so that I can't see it. All I would have is just 2y equals 6. I know that y is going to be 3. So my y-intercept is going to be 3. So I'm going to go ahead and plot that. 1, 2, 3. There's my y-intercept, okay? Now, if I was going to get my x-intercept, I need to cover up my y and pretend like that's not there. If I have 4x equals 6, I have to divide each side by 4. Now, I know that's not going to come out to a clean number. 6 over 4 reduces to 3 over 2, which I know that's the same as 1.5. That means that my x-intercept over here is going to be 1.5, and that's okay that it's not like a clean integer. It's no problem. And then you would just connect with the line and you would pretend like it actually goes through both points. Oof, yikes. Okay, last part here. Another advantage of using standard form is it's very easy to utilize with word problems when you have to translate a word problem into an equation. So if you have a media download store, which what is that? I don't even know at this point, especially in this day and age. If they sell songs for $1 each and movies for $12 each. Okay, pause right there. That would be literally $1 to buy a song. Could you imagine? You have $60 to spend. Can you write an equation to model that situation and identify different situations that could occur? So, like, you've got $60. How many different combinations could you buy with songs and movies? So, $1 for songs, we'll do 1x for that. And technically, you don't even need the coefficient of 1, that's just implied. Plus 12y, and then equals our total, which is 60. It is in standard form because you've got your constant with their coefficients there, and you've got your constant here. There's no fractions. Now, if I come over here, I'm not going to ask you to actually graph that yourself because you'd have to have all the way up to 60 on your x-axis, and that would take you forever. But if I did, it would look something like this, and then any point that falls perfectly on the line would be different combinations that would work. So, for example, you could buy 0 songs and 5 movies for $60. 24 songs and 3 movies, that would all add up to $60. So any point on that line that you graphed would make it possible. That's a situation that would work to satisfy that $60 total. That was a lot of information for one video, so good job sticking with it. Yay for you. One day down of the week. Okay, your assignment for today is the standard form quizzes. It is linked in the e-learning folder for you. All I ask is that you please use your first and last name, okay? Other than that, you guys are wonderful and great. See you later for our live session. Bye.